Hey friends, nice to see you once again in Mathematics Lovers Club. Welcome to Mathematics Lovers Club. Hello students, we have already seen two methods of division. One was Arthur Benjamin method and the other was the flag method. And as I have told you already, both these methods can be used for any divisor. But today, I am going to show you one more method of division that is called as the Nikhilam method or complement method. And this method will be used only when the divisor is very close to a base. Now, let us just go through the concept of base. We have already seen about the standard bases. Now, what are the standard bases? Now, the powers of 10, like 10, 100, 1000, these are the standard bases. And in the Nikhilam or the complement method, whatever is the divisor, we are going to take first the complement of it. Now, complement is the difference between the number and the closest standard base. And to find out the complement, we will use all from 9, last from 10, this particular rule. So take for example, 87. Now for 87, the nearest standard base is 100. And I am using all from 9 and last from 10, this rule. So except the last digit, all other digits, I'll subtract from 9. So 9 minus 8 is 1. And the last digit I will subtract from 10. So 10 minus 7 is 3. So complement of 87 will be 30. So the complement will show the difference between the number and the nearest base. So let us see some of the problems on this particular method, that is the complement method or the Nikhilam method. So let us come to the first problem here. 1013. I want to divide by 87. Now, as just now I said, for 87, the standard base is 100. And now since 100 has two zeros, last two digits I will put in the remainder column, remaining in the middle part of the table. Here I am writing the divisor 87 and the complement is 30. Keep it in mind that in flag method as well as Arthur Benjamin method, only the last digit was kept in the remainder column. Now here, depending on the base is 100, last two digits will be in the remainder column. If the base is 10, only one digit will be in the remainder column. So now, I am getting the first digit down here and I will multiply this quotient figure with the complement. Now, 1 into 13 is 13. So 1 I will write here and 3 here. And that will give me the second figure of the quotient. 0 plus 1 is 1. Now again, multiply 1 by 13. So that you write like this, 1 in the third column and 3 in the first column. And now add 3 plus 3 is 6 and 3 plus 2 5. And that will give the quotient as 11 and the remainder in this case will be 56. So as you can see here, this is comparatively an easier method, but can be only applied when the divisor is near to a standard base and below the standard base. Now let me take one more problem on this method. I'm going to divide 5,623 by 91. So again, for 91, the base, standard base will be 100. So I'm going to write the last two digits in the remainder column, 5 and 6 in the middle part of the table. Now here, the divisor is 91. And if I use all from 9 and last from 10 rule, I will get 0, 9 as the complement. Keep it in mind that even though the complement is only 9, since the base is 100, 100 has two zeros. So instead of writing only 9, it is better to write it as 09, two digits. So again, I'm getting 5 down here. I'm multiplying 5 with the complement figure. So that will become 45. And 6 and 4 I'll add. That will give me 10 here. Now I'll multiply 10 with 09. That gives me 90. And when I add this, I'll get 163. Now 163 is the remainder here. But keep it in mind that I'm dividing by 91. So the remainder cannot be greater than 91. And hence I'll divide 163 by 91 once again. And that will give me the quotient as 1. 91 ones are 91 and 163 minus 91 is 72. So the remainder is 72 here. And the quotient 1, I'm carrying forward. So this will become 11 and this is 5. Now as we have already seen, these are the digits of the number. So quotient cannot have 11 as a digit. So keep 1 here and carry forward 1. So 5 plus 1 is 6. So that will give the final quotient as 61 and the final remainder is 72. And as I already taught you, if I multiply this quotient 61 by the divisor 91 and add the remainder 72, I'm going to get 5,623. So now I'm going to give you one problem for practice and I'll give you time. So the student who will finish can tell me, come on the board and show the steps. So here, there is one problem for you as a practice problem. 3012. Divide this by 89. I'm giving you some time. And I think Vicky is ready with the solution. Vicky, please come on the board and show your steps on the board. Yes, sir. I completed my solution and I am showing that on the board. So here, again for 89, the base will be 100. So I'm writing the last two digits, 1 and 2, in the remainder column, 30 in the middle part of the table, and the divisor is 89, using all from 9 and last from 10. I get 9 minus 8 is 1 and 10 minus 9 is 1. So the complement is 11. So I'm getting 3 down. I'm multiplying this 3 by 11. That gives me 33. So the second quotient figure will be 3. Again, I am multiplying 3 by 11. That gives me 33 again. And this is 5, 7. So the quotient is 33 here. And the remainder is 75. So, sir, please tell me whether my steps are correct or no, and whether my answer is correct. So, students, this is a problem for you for practice. Divide 2023 by 85, and you should get quotient as 23 and the remainder as 85. So, as you can see, this particular method, Nikhilam method or the complement method, is easiest out of the three methods, but it is a very specific type of method. Specific in the sense, here you can apply the method only when the divisor is close to a standard base and below the standard base. So I will see you soon with some more tactics in Vedic mathematics. By that time, enjoy the day. See you soon. Bye, friends. See you soon. Enjoy the day ahead.